And so we're going to start looking at distances, midpoints, and slopes, which is super important for geometry, but it also transitions over into the algebra stuff as well. And even when we get into tomorrow's lesson, you're going to be thinking, wait, am I back in algebra? Because we do have to do some of those things, because we have parallel lines in algebra, you have perpendicular lines in algebra, and so we have some calculations to do. And for some of you, that makes you very happy because you prefer algebra over geometry anyway. But here we go. We're just going to remember a couple of things. We're going to remember that the distance on a number line is taking this coefficient minus this coefficient, and then their absolute value. We had done that before, but just to remind you of that, because we're going to be putting a whole bunch of things together. So you need to make sure that you can redo that. So if I want to find the distance from A to B, we have to put it in the absolute value bars. So you're doing negative 15 minus 3. So that would mean the distance between these is how much? If you go ahead and do that math. What'd you get? 18. And here's how this looks. And then when you do the math, you always do what's inside the absolute value bars, treat them as a grouping symbol. So you do them first and then take the absolute value. So your distance is actually 18. Be careful not to get caught in the common mistake. Sometimes people will see absolute value bars and try to make them positive and do like 15 minus 3 and then get a wrong answer. So be really careful that you do the work inside first and then absolute value bar at the end. So we've got 18 as our distance between them. Remember, this is different than when there's a little bar over top. The little bar over top talks about the segment, but just the two letters next to each other are telling you that it's the distance between those two things. We have another distance formula that we use when you have numbers on an ordered pair. So it can get more complicated. So we have this formula that we use when you have not just two numbers on a number line, but two numbers in a coordinate plane. So this should look somewhat familiar because you're seeing x1s and y1s and x2s and y2s. That should put you in mind of the fact that that's not the first time that you've seen the x1s and the y1s and the x2s and the y2s. And they represent ordered pairs. So we want to take a look at that next example that you've got there. And it is drawn in such a way that I did not put the grid lines on there because I want us to be able to be good at calculating these using the distance formula rather than trying to estimate by counting. So let's take a look at this. You have this problem right here. You have graphed points. You have -1, -3, and 5, 2. And we want to find the distance. We want to find the length of this piece. And in order to do that, we use our distance formula. And we want to identify your x1 and your y1 and your x2 and your y2. As I said, this shouldn't be the first time that you'd be able to identify these. Anybody think of another time when you identified the x1 and the y1 and the x2 and the y2, something you did way back?
We were doing like the same thing, trying to figure out which one it was.
Yeah, to figure out something else, and you said what? To find the slope. So doing basically the beginning same process as finding the slope. You have to identify the x1 and the y1 and the x2 and the y2. And so what we do then is take those numbers and plug them into this formula. Even though it's a really long formula, it comes in one piece after the other. Do watch out for your minuses and your negatives. Make sure you x2 negative 1 minus 5 squared. Negative 3 minus 2 squared. Negative 1 minus 5 squared. Negative 3 minus 2 squared. And then use your order of operations. Work inside your parentheses first. And do that step. So we've got negative 6 squared plus negative 5 squared. I do want you to be super, super, super careful, because when you are doing this math, you should not be, after you've done the squaring, you should not get any negatives under this radical, okay? Sometimes people forget to turn a negative times a negative into a positive, so be careful of that. This method will always give you positive answers. So negative 6 squared gives you 36 plus 25. And we get this interesting answer of square root of 61. So if you have your calculator handy, you should practice this. If not, and if people want to quietly, you can kind of get yourself one. But you need to take a look and make sure you can find a square root. You can help each other to get those. Thank you, thank you. We need to be able to find a square root. So you've got your calculator ready. Thank you, gentlemen. And you'll notice on your calculator there are numbers, there are little things above the keys. Okay? And the little things above the keys that are in yellow on this, but on the TI-84s, they're in light blue. You use the second button to access them. So if you use the second of x squared, that's your square root. And you have your square root key here. And then you put in the number you're trying to find the square root of. And it'll give you an answer. Okay, so everybody practice doing that. The second of x squared gives you the square root. We find the square root of this number. It's this long non-end decimal. It's really an example of an irrational number. These numbers would go on and on and on forever. We don't really have a pattern to it. It's important to be able to use your calculator to get these decimal approximations. There's other times when you know from, or you will know from later on, that we want to have our answer in radical form, but in this case we're just looking for a decimal approximation. So from that calculator value, it's about 7.8. Always use your rules of rounding. So if we're rounding to the tenths place, you look at the decimal place 1 to the right of it, and if it's a 5 or greater, you round up, and if it's below 5, you keep it the same number. So you use your rules of rounding correctly when you do these. This squiggly little equals might be new to you. This little thing that looks like an equals is telling you that it's approximately equal to. So equal to, but it's about 7.8. So make sure that you are able to take a square root on your calculator on these. God bless you. Okay. Very abrupt. All right. Whew. So we also did another thing on a number line. I'm bouncing back and forth here a little bit because we've got a couple concepts going. We've got the idea of distance, or how long the segment is. And then we've also got the idea of midpoint that we talked about before. So we need to make sure that we're keeping the concepts separate and being able to do the right idea for the right thing. When we found the midpoint, you needed to add the two numbers and divide by 2. You're really finding the average. You're finding the middle point. That's what a midpoint is. So negative 15 plus 3 divided gave us negative 6. So right there, the midpoint is found by taking the beginning plus the end dividing by 2. Nice and simple when you have just one number line in one dimension. What we need to do is we need to extend that also to your same picture. We need to extend that also to what do we do when we have ordered pairs. And we have another formula using the x1 and the y1 and the x2 and the y2. So let's take a look at that formula. It's the first formula you might have encountered where your answer is actually an ordered pair. Notice it still involves adding the coefficients and dividing by 2, but since there's an x direction and a y direction, you have to do it twice. You have to do it for the first one, and you have to do it for the second one. So when we go back to your problem that we had, okay, back to this problem, same line. I want to do something different though with this segment this time. I want to find the midpoint, the exact middle. Once again, I purposely didn't put it on graph paper because we don't want to just guess what the midpoint is. We want to actually calculate the midpoint. So we'll do the same process. You've got x1, y1, x2, y2, and that will be your first step. Just like when you're finding slope, just like when you're finding the distance, you have to identify your 1s and 2s and in these things. You always have an x and a y together with the same subscript, an x and a y together with the same subscript, x1, y1, x2, y2, and then you'll plug it in. These parentheses are super important. Sometimes I notice that some students tend to think of certain things like parentheses and brackets and braces as being optional, but they have meaning and they convey a meaning in your math. So if you don't put them, you're really not giving a real answer to a problem. So please make sure that you're including the parentheses in this calculation. So x1 plus x2, y1 plus y2, and then divide by 2. It's okay to get a decimal in these. So the first answer is 4/2. The second one is -1/2, but then always reduce as much as possible. -1/2 can't be reduced anymore, but 4/2 turns into 2. So our midpoint here, our answer, our midpoint is 2 -1/2. And we want to think about what that looks like on your graph. 2 -1/2 would really be over 2, down 1/2, which does actually show up on your line. Over 2, down 1/2. And that does, and visually it looks like, which it really should be because that is actually the middle point, the midpoint dividing it into 2 equal halves. All right. So far, so good. Question? No? Okay. So we have a little bit of an upscale on this one. I want to take this carefully here. Let's copy this. We're going to put it on something that I can write with, because I want to go through this one. There we go. So if we're given the midpoint and we're supposed to find the others, I want to go through this step by step with you. Okay, first of all, we need to think about our midpoint formula. Okay, our midpoint formula was what? Beautiful. x1 plus x2 over 2 plus, comma, y1 plus y2 over 2. That's good. Reading is a good thing. It shows that he's paying attention. Good job. Okay, so here's what is 1 and 1 1/2. So this is our midpoint. Our midpoint has an x component and it has a y component, an x piece and a y piece. And C is -4/6. We want to find out how much D is. C is -4/6. Here's our x1 and our y1. But D, we don't know what that is. That's our x2 and our y2. This one's taking it to a whole different level. But our midpoint, though, is -1 1/2. So our x part, somebody's light bulb went on. That's good. We have this, our x part. This part right here equals which one of these numbers? -1. Good. So -1 equals x1 plus x2 over 2. So what number do we know from this? Go ahead. The -4 goes in here. All right, so -1 equals -4 plus x2 over 2. So we're going to solve this. Now this is just a little tricky algebra, but not too much. I need to get this 2. This whole thing is divided by 2, so multiply. Good, good. We're going to multiply both sides by 2. Multiply by 2. And when you multiply by 2, these 2's cancel out. And we have -2 equals -4. So x, because we have to add 4 to both sides for those that missed that. So we have x2 is part of our answer. We need to repeat the process, though. We need to repeat the process. All right, so he wants to see the bottom. There we go. See? It's finished. You can do the same thing by multiplying both sides by 2 again. When we multiply by 2, the 2's cancel out. And we have 1 equals 6 plus y2. And y2 then equals -5. So our answer then, you have to put the 2 together so that the coordinates for D is 2, -5. So the midpoint between -4/6 and 2, 5 would be -1 1/2. So this one formula takes it to a whole level because you have to do all of those other things. But there you go. Is your or 2, -5 is your final answer. All right. there's there's some things you can do in your head. Now, the only caution I would have, I'm not quite sure where you're asking to see. Here? Okay. All right. The caution I would have about doing things in your head is that if you make a mistake in your head, I can't. If you make a mistake on the paper, then if it was just like adding or subtracting mistake, I can see what you did. You just put a number. And I found that on a recent quiz that somebody put a number. I'm like, oh my gosh, I think they just did the wrong. I think they know what they're doing, but they did the wrong thing. That work with simple things. So I'm like, the number's wrong because I wanted to be able to get it. So actually, it was a couple people. If they put the work, I would have been able to give them 3 points instead of just none. So anyway. And then I can give you the maximum number of points. All right, we have that. There's that. And we can't forget the slope formula that you've known from algebra from a long time ago. Okay, so the slope formula, y2 minus y1 over x2 minus x1. We're going to do the same process with the same graph, but finding the slope. What? I can. I'm trying not to use names, but if you don't mind if I use your name, then I can use your names. Okay. All right. All right. Because they might hear your name on the thing, so it's okay. All right. That's okay. Good. So Chief wants his name on there. That's good. All right. Here we go. Here we go. We need to find the slope. So we need to set this up. So you find the slope. Do the same thing. Identify x1, y1, x2, y2. Same beginning process. Because all of these three formulas use the same thing. Yes?
Does it matter that 5-2 is always first? Because I thought like when you go across the first plate that you hit.
If you want, you could make this one x1, y1 and this one x2, y2. The math will work out the same. You'll get the same answer. It doesn't matter as long as you put a 1 with a 1 and a 2 with a 2. And you always have an x and a y. Because if you put a 1 and a 2 together, or you put two x's together, that's not what the order pair means. So just be careful with that. It doesn't matter which one you choose to be 1 and which one you choose to be 2. So we're going to do this. As we're doing this, what number minus what number? Okay, wait, go ahead, Chris. -3 minus 2 on top, and on the bottom you get -1 minus 5. Do be careful of that. Once they're labeled, use the formula exactly. Okay? And there is a common mistake that people make, and like either reverse the x's and y's or kind of randomize the order, so do be careful. So -3 minus 2, watch out for your positives and negatives. That gives you -5 over -6, which gives you 5 over 6. And don't forget from back in the day, slope is rise over run. So if we were to count this, we're expecting it to be 5 over 6. 1, 2, 3, 4, 5 over 6. 1, 2, 3, 4, 5, 6. So that's what the slope is actually telling you. You want to make sure that you're keeping in mind that all of these numbers and things that we do have meaning. So not changing it yet. Yes. It's not absolute value. If you had a negative over a positive, it would be a negative. Or positive over negative gives you negative as well. Yeah.
So technically, couldn't you that, and then you would just get the midpoint, but it would be in the
Midpoint's something different. This is a slope. And if you reversed,
That's what I meant to say. Sorry.
it's okay. If you reversed, but I wanted to say that because sometimes people do get confused. I thought you knew, but I just wanted to make sure in case somebody else. So if you reversed this and you did 2 minus -3, you'd have a +5, and 5 minus -1 would give you a +6. It would still give you positive 5/6. So good. Yes, you can reverse them. You want to keep in mind, just by visually seeing what the slopes look like, because if you can visually understand what the slopes look like, and you know ahead of time whether you're expecting a positive or negative number. Positive is like this, you're kind of thinking going up. Negative is sliding down. Zero slope is if you would be maybe walking on a level surface. And then an undefined slope would be something that would be impossible to climb up. Okay, so you've got those things happening. There is a lot of things in this, but they're all very relevant, and they're all things that you're going to use through the years, so these ones are super important. I'm reviewing with you, remembering from Algebra 1 that parallel lines have the same slope. Okay? And if you were never told that before, I'm telling you now that parallel lines have the same slope, in case that got neglected in your Algebra 1 course wherever you had Algebra 1. Perpendicular lines have slopes that are negative reciprocals. Now, a negative reciprocal is when you have two numbers, like for example, 2 over 3 is a negative reciprocal with -3 over 2. Okay, 4 over 5 would have its negative reciprocal of what? -5 over 4. 1/5, -1/5 would have a negative reciprocal of just plain 5 over 1, which is 5. Okay, and I got you for a question in a minute. The negative reciprocal of 7 would be -1 over 7 because there's a hidden 1. What's your question?
Doesn't matter where you put the negative in brackets.
It doesn't matter. It doesn't matter if the negative is in the numerator or in the denominator or in front of the whole fraction. So it doesn't matter at all. Good question. For perpendicular lines. So that's what the parallel lines have, the same slope. Perpendicular have slopes that are negative reciprocals. So the reason that I'm telling you that is because you need to be able to count and possibly find out if they're really parallel or they're perpendicular. So you have a graph with 3 lines that look like they're all parallel in front of you, but in reality only 2 of them are parallel to each other. And we can do that by taking a look at the slope. You want to count rise over run on these, but make sure that when you start to count rise over run, make sure that you're like really at a place where you have an intersection, because some of them don't. Like here's one that's an intersection, and here's one that's an intersection. So my rise over run would be what over what on this one? Yep. I'm seeing 2 over 5. Up 2 over 5. So 2 over 5 here. 2 over 5. And this one, even though it's giving me a hard time as far as the writing, and I can't figure out why sometimes it does and sometimes it doesn't. Nope, not doing it. Okay, this one is going to be, if we put our dots in, this one is here and here. 1, 2, 1, 2, 3, 4, 5. This one's also 2 over 5. This one, here's a spot. And here's a spot. Is it 2 over 5 again? It is 2 over 5 again. Okay, so they actually look like it. I think it tilted a little bit on my other one that I had, so just be careful that you're putting it right in the corners when you're looking at that. Please don't giggle and laugh. You're not helping anything. Okay, so for these, if we do pick those spots that are right in the corners, we get 1, 2, 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. Yeah, it did kind of look like that. So they are all actually parallel in this case. This got tilted. I meant to do, it wasn't supposed to. This one was meant to be here so that we had a 3/8 on that one. But it didn't quite come out there, and we have to go with what it actually came out to be rather than what it, because I don't want to confuse you. So all three of these are parallel. Let's go on with this. Determine the slope. So we want to really quickly just practice finding the slope. So let's do that. I'll put it on pause while you guys take a minute and find the slope of these three lines, because there's no point in having them all listen to you do them. Okay, so after you've had a chance to work a little bit, we'll check these out. Remember, it's y2 minus y1, 4 minus 5 over negative 2 minus 3. 1/5. This one minus 6, y2 minus y1 over x2 minus x1, negative 2 minus negative 3, minus negative, remember from back in the day, turns out to be plus positive, so you get a positive one, so negative 5/1. And then this last one, 1 negative 13 minus 8, turns out to be 1/5. Knowing those three, we can determine which ones are parallel and which ones are perpendicular. So out of these, which ones are parallel? We do 1, 2, 3. You've got them labeled then. Yep, parallel. Wait. 1 and 3 are parallel. Good. 1 and 3 are parallel because their slopes are the same. And then which ones are perpendicular? Go ahead. 1 and 2. Okay. Also, what else? 3 and 2. Good. And there was another that also knew that. So just to finish this off, 1 and 3 are parallel lines because their slopes are equal. 1 and 2 are perpendicular, but 2 and 3 are also perpendicular. And if the slope came out to be something that was not equal and it wasn't a negative reciprocal, it would be neither one. And that will wrap up what we've got for today.